Hello everyone, my name is Chirag Patil and welcome back to my YouTube channel. So in today's video, we will learn how to train a convolutional neural network. Okay, so till now we had seen AlexNet, VGGNet, ResNet and InceptionNet architecture wise, and we had explored a research paper and implemented it using PyTorch, right? So in all of this video, we haven't trained any neural network yet, right? So in today's video, we will learn how we can train any CNN network, right? So for that, I will use our AlexNet notebook, which we had created in the AlexNet video, right? So I will utilize that code for the model part and we will implement training part. So first of all, for the training, I am utilizing this dataset, which is basically a simple dataset, cat versus dog, right? Which contains the 500 images of cat and 500 images of the dog, total 1000 images, right? So I just downloaded the dataset and converted into train and test split. So basically here train set has 400 image of dog and 400 image of cat, and test contains 100 images of dog and 100 images of cat. Okay, so let's get started. So first of all, let me import and first of all build the model, right? Because we already know how the AlexNet was built, right? And as we are using the two class classification, cat and dog, so I need to pass number of classes will be 2, right? So now our model is created here. So now we need to write our training script. So before starting the training, we need to pre-process our data, right? Which is basically image. So I'm just importing few libraries and now let's write some augmentation code, right? So if you see, this is the AlexNet paper, and if you go to the augmentation part, yes, data augmentation. So what they are suggesting here, so what they had done, they say we do extract the random 224 patches from the 256 by 256 images. So what they are basically doing here, they are resizing the image into 256, then extracting or randomly cropping the center part of 224 by 224 of the image, right? But we had understand in AlexNet video that AlexNet's input size is not 224 but it is 227. If you don't follow the 227 image size, you will not get this all the numbers, right? So if you haven't recalling that, you can go back and refer my AlexNet video where we had discussed this in detail, right? So our input size will be 227. So we need to write this code to transform our images, okay? And the second thing what they are using horizontal flip to augmenting the images. Let me search that as well. Yeah, here. So if you see the first form of the data augmentation, they are horizontally reflection. So they are flipping the image horizontally. So if you see, let's say we have image of dog. If you flip that horizontally, it will still have the dog, right? So that's why we are using this augmentation technique. So we can increase our data set. So as of now, we have only 400 images in the training, right? So if we flip, we can get double images. One is original image and other one is flipped image, right? So let's write that code here. So for that we will use this transform method of torch. So let me first write transform train, right? And we will use t dot compose. And here we need to pass what we need to perform on the image, right? So first will be we need to resize image, right? So let's say t dot resize, and in which we will use 256 dimension, right? So because first we need to convert it into 256, then we will crop the randomly, right? So then we need to use, let's say, randomized crop. Where is it? Yes, so it is randomized crop. Then we will pass our 227, which will be our image size, or it will be model input size, right? Then we need to randomly flip, right? Horizontally flip. As they had mentioned, they use horizontal flip. So let's say random horizontal flip. Yes, this one. So we are applying random horizontal flip, right? Now we need to convert this image into tensor. So let's say to tensor. And other thing, they are using a normalization technique, right? So if I find, so they are using normalization, normalizing the image, right? So while any competition or any model which are trained on the ImageNet, they are using ImageNet mean and standard deviation, okay? So Let me share something here. So let's say ImageNet normalization, mean and standard deviation. Okay, so if you see, these are some numbers which are used to normalize the image. So basically normalizing is you can think as a standard scalar which we are using in scalar kind of thing, right? So it is basically x minus mean divided by standard deviation. So you are normalizing your image. So this first part is for the red channel, second is for blue channel, sorry, for the green channel, and third is for the blue channel. So RGB mean and RGB standard deviation. It is calculated from ImageNet dataset, right? So we will utilize it as it is. We can write our own mean and standard deviation if we want. So for as of now, we will utilize these numbers. Okay. So let me write it here. Then we write t dot normalize, and we need to pass mean and we need to pass standard deviation, right? So let's utilize this number. And if you scroll this Stack Overflow page, you will find this mean ImageNet is common practice, right? So they are using commonly, if you use VGGNet, ResNet, which are trained on the ImageNet, they are using this mean and this standard deviation. Okay, so let's provide the mean value and let pass standard deviation, right, which will be this one. So this will be our training transformation part. What we are doing, we are resizing 256 and randomly cropping to 27, which is our input size. Then we will flip our images to increase the number of images. Then we are converting it to tensor, and we will at the end we will normalize the image, right? So same we need to write for the test part as well, right? So let's say transform test will be t.compose, and we will utilize all this part except this random. Let me write first and then I will explain. Okay, so for the testing we need to resize it, right? Then we need to randomly crop. So let's say in the testing we can use center crop as well, right? So let's say t dot center crop. So image will be cropped in the center part of the 256 image basically, and we don't need this random horizontal flip, right? Because for the testing we do not require increasing the image size or providing as much as variation, right? Because model is already trained, now we are just testing it. So we need to convert it to tensor, and we will use the normalize, right? So same mean and standard deviation will be used at the test time as well. Okay, so this is our train transform and test transform techniques. So now let's create a data set. Okay, you need to take 2 positional argument, but 6 were given. Okay, what is the issue? Oh, okay, in the compose we need to provide a list of the operation we need to perform. Okay, so this will be in the list. Let me write it here. Yeah, so this should be in the list. Now let's run. Yeah, now it's working. Okay, so now we have our transformation technique ready. Now let's create a data set. Okay, so this is the data set is here, but we need to convert in the PyTorch data set basically. So let's say train data set. Train data set will be, we will use data sets which is imported here. Okay, from the torch vision. Train data sets, as we have the data in the image folders, right? So we will use from the image folder basically. Let's say datasets.image folder. We need to pass, what is happening here, datasets is not defined. Okay, it would be datasets, right? So we need to pass the root directory where basically our images is. So for the training part we need to provide our training path, right? So it would be cat versus dog train, right? And we need to provide transform techniques here which we had created here, right? So let's say transform will be transform train, right? Same we need to create for the testing. Let me copy paste it. So first will be, let's say test dataset, root folder will change to test, and here we need to provide transform test techniques, right? So here we had created the data set using torch from the image folder. Okay, so now this is whole data set our. So now we need to convert it into data loader, so we can iterate over each batch, and we cannot it will not consume much RAM to loading whole data set at once, right? So we need to create iterator. So for that we are using data loader basically. So let's say train data loader, or let's say train loader will be data loader, right, which we had already imported here. Let me show you this one, utility.data loader. Okay, so in data loader what we are going to pass, we need to pass our data set basically, right? So it is train data train loader, so we will pass data set is equal to train loader. Okay, and then we need to provide a batch size, how many batch size we required. So let's say we will initially use the batch size is equal to 64. Then let's say shuffle, we are providing shuffle is equal to true, because we need to, in the training we will use shuffling, right? So here it should be not train loader, it should be train data set, right? So these are the argument which we required basically. So data set, batch size and shuffle. Okay, now let's create a test loader. Test loader will be same data loader, and we need to provide a data set is equal to test data set. Then let's say batch size we are providing same, which will be 64, and then shuffle. So for testing we don't require this shuffle, right? Okay, let's say false. Simple. So now we had also created the train and test loader as well. So now we need to write our training pipeline, right? So model can train on that. So for training what we required basically, we will require optimizer and our loss function, right? Basically, or criteria you can say, on which we will train our model. So let's say first define our criterion, right? So let's say criterion will be, so we are using cross entropy here. Okay, as it is the classification task, we will use cross entropy loss. Okay, the second thing we will use optimizer. So for optimizer, in the paper they are mentioning they had stochastic gradient descent, right? So let me show you. Yeah, so they mentioned we trained our model using stochastic gradient descent with batch size 128, because we don't have that much data set. We are using smaller batch size, which is 64, and momentum is 0.9, and weight decay will be 0.0005, right? So let's write, and then I will explain what does it mean. Okay, so first we need to write, let's say optim.sgd, right? Sorry, it would be sgd, which is stochastic gradient descent, and we need to pass model.parameter here, parameters. Then second thing we will pass a learning rate, which will be the LR, which is the 0.01. They had also mentioned in the paper they started with 0.01. Okay, now momentum we had seen 0.9 they had mentioned, right? And the second last thing, it's weight decay, right? Weight decay, which will be 0.0005. So we can write it like 5 e raised to minus 4, right? So it will be 0.0005 basically, the same as mentioned in the paper. So what is the weighing decay here? So it is nothing but we are adding it as a regularizer, so our weight cannot be much larger. We are adding our loss plus final loss will be loss plus the sum of weight square multiplied by this. Okay, so this will be performed as a regularizer. We are using L2 regularizer mostly, so this will be a sum of weighted square of weights, and after that we will multiply it with this weight decay number, right? So if you know the machine learning part, so we are using lambda into regularizer, right? So weight decay is nothing but that lambda part. Okay, so now our optimizer is created. Let's run it. Okay, so it's working. So now finally let's write the training part, right? So I will create one function, let's say train model, and we need to use first model will required, we require train loader. The second we require our criterion, and then we will require optimizer, and how many epochs we need to train, right? Number of epochs. So first of all, let's say I'm just defining some variable. Running loss will be 0, correct will be 0, total will be 0. So bear with me, when we will implement, you can understand why we are writing this number. Okay. So now first of all we need to iterate over each batch, right? Because we need to train our model. So we are writing for I, data loader will return basically inputs image, which will be, let me write inputs, and second will be labels, right? In enumerate train loader, right? So if you iterate over the loader, it will return inputs and labels. Inputs will be our images and labels will be cat versus dog or binary 0 or 1, right? So now let's extract inputs will be inputs label. Okay, so first thing, as we are using GPU here, so we need to convert our model into GPU format, right? So let me write that part first. So first of all we need to check whether device we have the GPU or not. So let's say device will be, I need to write torch.cuda, right? So let's say torch.cuda. So let's write in the way that if you don't have the GPU, still it works, right? So let's say torch.device, and we write CUDA if torch.CUDA dot is available, right? Sorry, that is a typo, is available, else it will be a CPU, right? So if torch.CUDA is available, we will use CUDA, otherwise it will be a CPU, right? And we need to convert this into also the device, right? So let's say we need to pass a device, right? So let's load the model in the GPU part. So now model is loaded in the GPU. Same part, we need to, if we are training on the GPU, we need to convert our data type or our input as well on that device part, right? So when we will use our images and labels, we need to convert them into a device. Okay, so let's say input and labels is equal to input dot to device and labels dot to device, right? So now our input variable and models are in the same device, right? So now first of all we will use, let's say, optimizer, and we will set all the gradient to 0, right? Why? Because let's say for currently it will be 0, but when you are training the model, for each batch we need to start from the 0, right? We will not utilize the previous gradient currently. So let's say it will be optimizer.0 grade, and now let's write the forward path. Okay, forward path basically in the optimizer forward path and backward path. Okay, not the forward part of the model. Basically what will happen in the forward pass, we will pass the input and we will receive the output, right? And then in the backward parts we will provide the loss, and optimizer will update the weights according to the loss, right? So now let's first of all, let's outputs will be model, and we need to provide the input, right? So it will return output in the number of batch size and number of classes, right? So now we need to create a loss will be calculated by our criterion which we had used, cross entropy loss, right? So we need to pass outputs and we need to pass a labels, right? So labels will come from the data loader and output will come from the models, right? Model output basically. So now let's provide loss dot backward. Okay, and now optimizer dot step. So here we are calculating a loss. Now loss will propagate to backward, and optimizer dot step will update the weights, right? So let me write update weights. So basically let me remove this forward. So we are doing all the part here, forward and backward propagation, right? So this thing is clear. So it is trained on a first batch currently, and if we will iterate over each batch and it will train our model. So now let's calculate the accuracy to print, right? So let's say what we need to do, we have the output and labels, right? So we need to create the accuracy. So let's say, let me write here, right, accuracy. So it will be, let's say we will use output dot max and we will providing the 1. So it will basically find max from first direction, so first dimension, because 0 dimension will be our batch size, right? So let's say what it will return, it will return a value and we can say index prediction, let's say prediction. So what we are doing, it will return a maximum output value and the index of it. So for example, we have two class basically, right, or 0 or 1. So whatever will have the max value, it will be our predicted class, right? So index of that will be treated as a predicted class and this will be a max value of it. If you apply on top of that the softmax, you will get the value between 0 value with sums to the 1, right? But currently for the accuracy we don't require, so we are just applying the output max. And one more thing, here we are not applying the softmax, and if you see the model also not applying any softmax, right? Because we are using cross entropy loss, it's calculate the softmax by default inbuilt, right? So for the loss value we are using this cross entropy loss, so we do not require to provide softmax output. Okay, so now we have our predicted labels. Now let's say total will be, so we are performing on the batch wise, right? So let's say total will be for this basically particular batch size, let's say labels dot size of 0. So basically let's say in this batch we are using 64 as a batch size, right? So this will return 64 and our total will be increased by the 64, right? Okay, so I think I have done one mistake. This 3 line should be inside the for loop, because for each epoch we need to calculate this, right? No, I think I had done again one mistake. So it would be like this. Let me write again. For epoch in range of number of epochs, right? So for what we had done, we are write the code for one batch, right, or particular one batch. So it will run for only one epoch basically. So I am writing here for loop, in that 3 part will be here. For each epoch we need to create need to use total, correct and running loss, and we will print that. When we will print, you can get better idea. Okay, so for each batch we are increasing the total size. So first batch will be 64, from the second it will be 128 and so on, right? So now let's calculate the corrected value and we will add into that our correct variable. Okay, so correct will be, let's say predicted dot eq. So it will be check the equivalent, right? So we are passing the labels. So okay, so what this, sorry, let me write, it would be like this. Okay, so what it will do, it will return a tensor of true and false value. When predicted and labels are same, it will return true, otherwise it will be false, right? So now what we will do, we will apply the sum on this. So basically true value will be counted as a 1 and false will be counted as a 0, and we are summing this all values, right? So when you sum, you will get the total correct value or total points which has the true label and the predicted value and labels are equal. Okay, and last we need to provide the item, because we need to convert it into a Python number format, right? It can be integer or float basically. In our case it would be integer here because we are counting number of points, right? And correct is our Python integer here. So we are converting tensor into our Python number type. Okay, so now this will be our correct point, and what will be the running loss, right? So let's say running loss will be plus or equal total loss, right? Loss is nothing but what we had calculated here. Okay, and as we know it is also a tensor, so we need to use item, so it can be converted into a Python normal type. Okay, so running loss will be this. Now let's print. So let's say if I is basically nothing but our each batch, right? So let's say I modulo, so we will print for each 5 batches, we will print our loss and accuracy. Okay, so let's say I modulo 5 is equal to 4. So basically I'm writing here as like, if for example let's say we are at 4th batch and we are modulo it is using 5, so we'll receive 4, right? So basically if you are, as we are starting from 0, so we need to use minus 1, right? So it 0 1 2 3 4, so it is basically 5 batch, right? So I am applying here 4, or you can do here one thing as well, in element you can start from the 1 as well, or you can provide 1 plus I plus 1 as well. So I am writing like this. So now we need to print, right? So let's say print, I will use app string. So let's say epoch will be epoch, right? And let's say number of batch, or you can say steps, right? Steps will be, let me write a batch size, right? Batch I, and let's say accuracy will be, let's say what is our correct divided by total, right? Total. And let's print the loss as well. So loss will be, let me write colon here, right? It would be, okay, so loss will be our running loss, simple, right? Because we are running loss, we are increasing it or adding the loss into the running loss, so it will be our running loss, right? Simple. So this two part we will plot for the each 5 batches and trend. Okay, so this will be our training pipeline. So what we are doing, we will iterating over each batch using the data loader, and we are providing or calculating the loss on the model's output, and then providing the backward propagation, loss backward and optimizer dot steps, right? Then we calculated our accuracy. For each batch we are just calculating the number of correct points, and we are adding at the epoch, and we will have final accuracy, right? Okay, so now this will be our training step. Now let's define the test step as well. It would be easy simple. So let's say model, and we need only test loader, right? Let's say first of all we need to convert in our model into eval step, right? So it will not calculate any gradient or something, right? And same we need to create here as well, provide the model into train mode, right? So this is the model train. Now we are using model eval. So now same, correct is equal to 0, total is equal to 0, and we will use with torch dot no grade. So it will not create any grade, calculate any gradients, right? Because on the test we do not require any gradient. So now we will follow the same path. Let's say I inputs, basically let's say inputs and labels in test loader, right? Okay, so now let's convert these inputs into, let me write, into device, right? It will be inputs dot device, sorry, it would be to device, right? And then labels dot to device, right? So now our input and outputs are converted into our device format, basically CUDA tensor. And then let's create the output, will be model, and we need to pass the inputs, and we are using same, let's say predicted will be outputs dot max of 1, right? Now total will be labels dot size of 0, which is basically base size, and correct will be, we need to use plus or equal, right? So equal predicted dot equal, we will provide the labels, and sum dot items, it should be item, right? So now we have this, and at the end we will just print test accuracy. Let me use app string here. Test accuracy will be correct divided by total. It will be written in the 0 to 1. We can multiply it with 100 if we want actual accuracy between 1 to 100, but it's okay for now. So this will be our test part, right? So now let's call the training model, right? So let's say train model, and we need to pass the argument, right? So first will be model train loader, the second we need to pass criterion, and we are using optimizer, and let's say we will train it for number of epoch only 10, okay, for to see how it perform. Okay, so we are just showing how training will happen. If you run it for the more epoch, you can get better result, right? So let's for the only run for the 5 epochs, so it can be easily done, right? So let's run. Okay, so there is error. Con2d received the invalid combination, got method parameter string tuple but expected one of. Okay, there is something issue. Let's see. Inputs to device. Okay, so here there is one typo. We need to pass inputs instead of input, right? Because the variable name is inputs. Let's see if anything else. Okay, so here also we need to pass step, right? Again one typo. Okay, so let's see, everything rest looks good. Okay, let's do one thing. Let's change this part. We will just print the accuracy and loss at epoch completion, right? So it will reduce the printing statement. So now let's print after one epoch. Okay, all batch are processed, so we are just passing the loss. We can do one thing as well, we haven't done yet. So let's multiply it with the 100, so we get the accuracy. Okay, so we can write like this, right? So this will be this much accuracy, and this will be our total loss, right? So now let's run it again. Okay, so we can change the number of epoch as well. Let's say 20, so we can get better. So as we are removing that printing statement more, so we can run it for the 20, so we can see easily, right? So let's run it, and let's see how much accuracy it will provide. Okay, it will take few seconds for one epoch. So okay, the first epoch we receive 53% accuracy and loss is 9.0. Now let's see for the second epoch. Yeah, so it degrade to 49.375. Let's see again. Okay, so it's improved from 53.87. Okay, so let it be trained for 20 epochs. I will I am stopping the video here, and I will connect again when this 20 epochs run. Okay, so after 20 epochs we receive very good accuracy, which is 90.625, right? So now let's run the test part and see the testing accuracy. Okay, so it would be test model. We need to provide the model and test loader, right? If you see, we have defined the model here, function here, test model and test loader it would require, and it will print the test accuracy, right? So let's run. Okay. So here also we are receiving 93% accuracy on the testing and 90% accuracy on the training, which is very good because this data set is very simple and CNN can easily learn this, right? If you have another data set, you need to experiment with multiple things, right? So this is how you can train simply a CNN network. So we used our LXNet model, which we had implemented in previous videos. So you can try this training script on VGGNet or RESTnet, and you can see how they are performing, right, and how much accuracy you are receiving on that model as well. So this is all about how to train a CNN network using PyTorch. If you have any query or doubt, you can ask in the comment section. We can discuss there. And if you like my video, please press the like button and subscribe my YouTube channel for more content. Thank you.